Sorry?
Never mind.
Can we do 2 and 8, mister?
So number 2, 7, and 8 is what I got. Can we do it? Yeah. We are gonna go all. I'm just gonna make sure if we have like those are the ones I for sure want to take up. In case we do run out of time for whatever reason. So 2, 7, 8 were the ones that people wanted for sure. Okay, cool. So let's go over all of it. I don't know why the graph didn't come out for that one. Hold on, let me see if I can get the graph for this one here. Give me 1 second. Oh, the graph is literally just missing. I didn't even realize the graph was literally just missing. Okay, so let's go over this here. First one, is it periodic or not? This is definitely periodic, right? And the period, once again, if you know there's a pattern, pick a point, any point that's on one of the grid lines. So for example, if I pick one here, ask yourself, look at what happens before and after. Does this happen again later? And the answer is yes. It happens again at this point. And how much x did it take for it to repeat? So this is x equals 3 here. So from 3 to 6, the period would be 3. Okay, it takes 3 units of x for it to repeat over and over and over again. And it doesn't matter which part you pick. For example, I could pick this part here at 4, and if I keep going and I find the same spot again, that will also be 3. Okay? So that's the important part here. Okay? Now the amplitude here. So for the amplitude, we can use the formula. If you remember the formula for the amplitude formula, I'll write it up here. I will give it to you tomorrow, but it's max minus minimum divided by 2. So for us, the maximum is 3 and the minimum is -1. So 3 minus -1 is going to be 4. 4 divided by 2 is 2. So the amplitude is 2. The axis of the curve. Where is the middle of our line here? Well, we can use the formula for the axis of symmetry. Or sorry, not symmetry. Axis of the equation of the axis here. The axis is going to be at y equals max plus min divided by 2. So for us, this time it's 3 plus -1 divided by 2, which is 2 over 2, which gives us y equals 1. And that's going to be the equation of the axis here. Okay, so y equals 1. The domain, you'll notice if there are arrows, we are assuming that it goes infinitely both ways. If I give you just one section, you're just specifying. So for the domain here, some of you may have just written like -2 to 10, possibly. But what I was looking for here for the domain is XER, and that's it, because it goes infinitely both ways. So look for those arrows. If you see those arrows, it goes infinitely both ways. So domain is XER. The range, once again, is going to be minimum is less than or equal to y, which is less than or equal to the maximum. So -1 is less than or equal to y, which is less than or equal to 3. And that would be our range here. So this is going to be how you solve for each of the key points. Yes, you will have a question like this on your test, which requires you to find those key points from a graph that you're looking at. Okay. That being said, next part here, is this periodic or not? This is also, yes, it is periodic. It repeats. There's a pattern over and over again. What is the period here? So I'm just going to pick a random spot. So I'm going to pick a point here. So I'm looking for a kind of like a V, right? After this, so there's going to be a curve and then an upwards triangle and then a V. So I keep going until I see that, and I see it again here. And so this was at 5, and we got all the way to 11. So what's the difference between the two? Well, from 5 to 11, it's going to be 6. So the period is 6. Okay. So the period is from where you start your cycle to the end of your cycle. Once again, this doesn't have to be this point in particular. I can pick any other point. I can pick this one. I'm going to do the top of the triangle here, or the mountain here, after the curved mountain. And then I keep going. I see, oh, there's the curved mountain. There's the top of the mountain. And from 3 to 9, it's also 6. So regardless of where you pick your point, the important part is pick your point. If you know it repeats, find it again, and you'll be able to find your period. Okay? So that's going to be our period of 6. The amplitude, if we use your formula, the peak is at the peak is at 4, sorry, and the trough, the lowest point, is at -3. So 4 minus -3 is going to be 7. 7 divided by 2 will give you 3.5. Yes, your amplitude can be a decimal. The axis of the curve, the equation of the axis, is going to be y equals max plus minimum. So 4 plus -3 is going to give us 1, divided by 2 is going to give us 0.5. Or 1/2 if you wrote it as a fraction. Okay? And the domain here goes both ways infinitely, so that's going to be XER. And for the range, it's going to be from -3 to +4. Any specific questions about this one here? Just going to quickly take attendance for those that said they were late. Give me a moment. Okay, remember, if you're late, let me know that you're late so I can update it. All right. So there are no questions in the chat right now. Let's move on to question 2. The minute hand of a clock is 12 centimeters in length and begins by pointing to the number 9 on the clock. Okay. So complete the table representing the distance of the tip of the minute hand above or below the level of 9 on the face of the clock relative to the angle of rotation for 2 complete revolutions, which means 2 circles. Goes around twice. So use your data to sketch the graph of the angle versus the distance above or below the level of the 9. Okay. So it tells us that the minute hand is 12 centimeters in length. So for us, when the minute hand, well, hasn't moved, it's at the 9 o'clock number, right? Then the height should be 0, right? So if we go 90 degrees from 9 o'clock, which is 12 o'clock, what's the length of the minute hand up top? 12 is correct, yes. Since the minute hand is 12 centimeters in length, it's just 12 centimeters above the minute hand. So basically what the question is telling you is saying, if there's a clock and 9 is our kind of line, then imagine there was like a horizontal line going across and it's measuring the minute hand going above and below this line, right? So at 12 o'clock, the minute hand would be 12 centimeters higher than this horizontal line from the number 9. That's essentially what's happening here. So then when we're back to 180, which is 3 o'clock, it would be back to 0. And then 270 degrees is going to be at 6 o'clock, which is -12. It's 12 centimeters below that line. And then 360 is a full rotation, which is back to 0, which is 9 o'clock. This cycle will repeat, and you should get these values here. Any questions?
Wait, can you explain it again? How? Well, got it.
So the clock, think about where 9 o'clock is. Draw a horizontal line from 9 o'clock. If you have a clock in front of you that has a face on it, use that as a guideline. And so it's saying at 90 degrees, it would be at 12 o'clock. Right? That's 12. And that's 12 centimeters higher than this horizontal line. 180 degrees is 3 o'clock. It's on the line, as it should be, because 3 and 9 are on the same line. 270 degrees is 6 o'clock, which is 12 centimeters down. So it's negative 12. And then 360 degrees is a full circle, right? Which will give us back to 9 o'clock, which is 0.
Okay,
And that
thank
cycle
you.
will repeat.
Thank you.
No problem. So once we have that there, we can now graph it. So the graph that I should see here is 0, 12, 0, negative 12, and that repeats over for 2 rotations. Now, I'm going to try my best to draw my terrible sine graph on... I don't know why I'm so bad on a tablet. Okay, good enough. Something like this. It's terrible, I know. But I should see like a curve that looks like this. I should not see like straight lines. This is bad. I don't want to see this. That's wrong. Okay? So as a result, we want to see a curve because we're talking about a sinusoidal function here. Okay? Now, how does this graph compare to the graph of y equals sine theta? Okay? So how does it compare? Do we have any transformations here? Anyone know? What are some transformations that you can see here? Anyone have any ideas? The peak is 12, yes. The peak is 12. The trough is negative 12, right? While for sine theta, well, I'll just write, I can't really write theta here on my calculator. But for sine, I'll just use sine x. It would be 1 and negative 1, right? So for sine x, the peak and trough would be 1 and negative 1. And then Brooke mentioned in chat, for this one though, the peak is 12 and the trough is negative 12. So it's a little bit different there. This leads to our second thing. If you remember, your vertical stretch and compression is your amplitude. And our amplitude here is 12. So for this graph, it has a vertical stretch by factor of 12. Okay? And the second thing I would like you to write here, at the bottom here, the equation of the axis is the same. In brackets, no horizontal or vertical shift. Right? Nothing has shifted. So these are the two things that I would like to see when you write something down. So number one here, you can see the peak and the troughs are different. And that means that it has a vertical stretch by a factor of 12. And second, the equation of the axis is still y equals 0. That's already true for y equals sine theta. So there's no vertical shift or horizontal shift or anything like that. Okay, so that would be for number 2 here. What I want you to realize, though, is understanding that you really need to get comfortable with identifying what y equals sine theta looks like. You shouldn't be... So before your test tomorrow, if I say, hey, what's y equals sine theta? You should know how to graph it using the 5 key points. Boom, 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 boom. You should know exactly what it looks like. what the peak and troughs are, where's the equation of the axis, because that's what you're comparing it to. That is your base function, right? When we did transformations with quadratics, the important part was understanding, I know what y equals x squared looks like, and then what does that look like transformed? Same idea here. You need to know what y equals sine theta looks like, and then what does that look like transformed? So that's what you want to focus on. So moving on into question 3 here. Okay. A toy tractor wheel has a radius of 1 centimeter, rotates counterclockwise, which is in the opposite direction here. So this way. A stone is embedded in the rightmost point. A graph of the stone's height relative to the center wheel is shown here. Correct each statement about the graph. Okay? So, number 1, we want to correct the statement. The wheel is 2 centimeters in radius. What's the actual radius? The wheel is 1 centimeter in radius. This links to the amplitude. So that's what you want to see here. Okay, the wheel is 1 centimeter in radius, and the 1 centimeter radius is indicated by the amplitude. The amplitude shows you what the radius of that wheel is. The stone begins in the uppermost position. That's not true. We know in the statement, the stone begins in the rightmost portion. Okay? And for here, if it started in the uppermost portion, it should start at 1. The graph should start at 0, 1. If it started at uppermost portion, the graph should start at 0, 1. So I want to make that clear here. If it was mentioned to be at the uppermost portion, that should be the highest point. It starts at 1. But since we said it started at the rightmost portion, it starts at 0, 0, 0. So little identifications of where you know we're starting. The wheel rotates clockwise. No, the question said the wheel rotates counterclockwise. And how do we know that? From the graph. If it went clockwise, the graph should go. Anyone have an idea? Because we've been told it goes counterclockwise. How do we know for sure it goes counterclockwise? What tells us that? What's the difference? If it goes clockwise, what should happen?
Should it start at its minimum first?
Yeah, that's right. It should go down first. And Franz is saying it correct. Reflection is the other way you can represent it. That is correct. So Sidney and Franz are talking about the same thing. It should go downwards first, towards the trough, right? Indicating reflection, right? So if we went clockwise, the wheel goes down to the bottom, which would be down here. You can't see that. Down here, right? Which would go lower than where it started. But since the graph went upwards, we would assume that it's going counterclockwise. So we can get a lot of information, right, from what's happening with just by looking at the graph and kind of seeing, oh, what's going on here? What's happening with the rock? How's the wheel turning? What's the radius of the wheel? These little key things can actually be seen on this graph by looking at some key pieces of information. That's very well done. All right. For A and B, writing an equation for each sine function. So just keep in mind, right? Y is equal to, whoopsies. Y is equal to A. Maybe I should do this in black and red for the transformations. Y is equal to A sine bracket X. Did I use h and k? Which variables did I use? I keep forgetting.
B
I
and
keep
D.
forgetting. C and D, right?
Oh, B and D.
Okay, there we go. So B and D. Okay, so we have y equals a sine bracket x minus b plus d. Now the key thing you want to remember here, once again, d refers to the equation of the axis, and a refers to the amplitude. Yes, you can use theta instead of x. That's fine. Yeah, both work. So in this thing here, if it tells us the amplitude is 5, this is telling us that a equals 5. Phase shift of 30 to the right is telling us that b equals 30, right? So our final equation would be y is equal to 5 sine x, or theta, minus 30, and that's it. So that would be our equation here. For part B, if you haven't done so, I'm going to give you a minute to create the equation for part B, and then we're going to take it up real quick. I'm going to give you a quick minute to solve it. Okay. I have someone who sent me their answer. If anyone else would like to send me their answer or type it in chat in 5, 4, 3, 2, 1, go. Type it in chat if you have it. You can DM me or send it to everyone. But let's check the answers here. The person I got it from is correct. We have y is equal to -2 sine x, or theta, plus 90 minus 9. And the rest of the people that have sent it to me are also correct, which is great. So that negative indicates that reflection, 2 representing the amplitude, plus 90 representing the phase shift to the left, and minus 9 representing the vertical translation down. Perfect. So if I give you this information, you should be able to give me the equation back, right? You can write the degree sign. I would suggest not to do so, because when you work with things later on, we kind of just want to leave it as the number. But that is a good question. I won't deduct marks if you put the degree sign, but I would suggest not to, just to get comfortable with. Just in mathematics, usually we don't write the units within our functions itself. Any other questions? All right. Then we move on to here. Sketch the graph of y equals 3 sine bracket x plus 60 close bracket minus 2. All right. So this is how it's going to work. First off, we draw our equation of the axis. What is it? It's -2. So I'm going to draw my equation of the axis at -2. Boom. Draw that line, make it a dotted line so that you don't forget. I'm going to make it a nice dotted line on y equals -2. For the amplitude here, we can see that the amplitude is 3. So what I do next is I essentially mark down 3 above the equation of the axis. So 1, 2, 3. And that's going to be the highest my graph is going to go. Maybe I'll do that in purple so that you guys can see a little better. So that's going to be the highest, and then -5 is going to be the lowest. So 3 up and 3 down is what I'm looking at right now, because the amplitude is 3. So up 3 and down 3. Okay? Now from here comes the tricky part. Oh, and Sophia, you're late. Okay, let me just update that real quick. And then I'm going to send in the attendance here. Okay. So now, originally, for our sine graph, we have to check, number one, well, is it reflected or not? It's not reflected, so it's going to go start from the middle. Normally, our original x value, if you remember, the 5 points are 0, 0, 91, 180, 0, 270, -1, and 360, 0. These are the 5 points for sine theta, or sine x. Okay? You want to take a look at these x values. These are the important ones. Okay? And all you have to do, since we're doing 60 to the left, we're moving 60 to the left. So 0, we're moving 60 to the left, is going to start here on the equation of the axis. So that's going to be our first point here. Okay? So sine theta, or sine x, starts at the equation of the axis. And for us, our equation of the axis is at -2 now. So that's going to be our new starting point, because we're moving 60 to the left. And then 90 minus 60 is going to be 30, and it's at the peak. So this is the peak, right? And then this is the trough here. So I'm going to go to 30 on the x and draw it on the peak, the highest point. And then this is going to be, it's going to be axis, peak, axis, trough, axis. So I'm going to go 180 minus 60 is going to be 120, and it's back to the axis. Then 270 minus 60 is 210 to the trough. And then 360 minus 60 to the axis is going to be 300, and that's going to be our graph there. And you can do it with an arrowhead on both sides because we're talking about the whole sine graph there. So hopefully that answers your question too, Sydney, on how to graph it a little bit. Hopefully that touched upon it.
Yeah, it did. Thank you.
No problem. So there, it's really important to break down your original sine x into these 5 points. So if you want to write these 5 points down, it's very important that you do so. Yes, Ashley.
I don't know how did you get the 30 and 1.
This one here.
No, the
Wait,
30. Yeah,
this
that
one?
Yeah.
So what I did was, since I moved 60 to the left, right? I look at the 90 and I subtract 60 because that's 60 to the left. So 90 minus 60 is 30, right? And then it's at the peak. So in our regular sine graph, this point is the peak. So I just find the peak of my new graph, which I indicated earlier with the amplitude, and I just draw the point there. So that's why it's, you see these purple lines? That would be the peak and the trough of my new graph. That's what I draw first.
Mister, is it
Yes.
always going to be axis, peak, axis, trough, and then axis? That's the
Yes,
pattern.
if it's not reflected. If it's reflected, it would be axis, trough, axis, peak, axis. So like the trough and peak would be flipped, right? Because it's upside down. Otherwise, this is true.
Okay, thank you.
No problem. Very good questions. That's very good. Keep the questions coming. Your test is tomorrow. It's always good to ask questions.
Mr. Char, I actually have a question. If it's reflected and you have to write an equation for it, would you put negative in front?
Yes, there should be a negative with the amplitude at the front.
So when it's reflected, it would be at the minimum first?
Yes, it would go axis, minimum axis, peak axis. So it would be the opposite direction. Okay. Very good question. So hopefully that clarifies a lot for people. So now let's do the reverse. What if I give you the graph on question 6 and then you give me the equation? The rules are still the same. Draw the peak. Where's the peak? Oh, it's at 1. Where's the trough? Oh, it's at 7. I'm going to draw that better. And then where's the equation of the axis there? Well, you can solve for it, right? If the peak is 1 and the trough is negative 7, you can do the math, right? The axis is y is equal to max, which is 1, plus negative 7 divided by 2, which gives us negative 6 divided by 2, which is negative 3. So then I can draw my equation of the axis. So my first two steps are the same. Indicate your peak, indicate your trough, indicate your equation of the axis. That's going to give you your amplitude, right? You don't even need to do the formula. You can just count. 1, 2, 3, 4. My amplitude is 4. Right? Very quick and easy. And now we look at the graph. We think, okay, I start at axis, peak, axis, trough, axis. Did my graph move? Am I starting at 0? Yes. So did it move? No, there's no phase shift here. So if we wanted to write the equation here, it would be 4 sine x minus 3. Right? The moment you find amplitude and axis, you've done most of the equation. The only thing you need to worry about is then phase shift. Did it move? Where did it move to? Okay?
Mister,
Yes.
please repeat it.
Yes, absolutely. So first step is to draw your peak and your trough, right, which are my purple lines here. And then using your peak and trough, you can solve for the equation of the axis using your formula, right? And then once you find the equation of the axis, you can draw that in, right? That's going to give you A and that's going to give you D immediately. So we already have those two pieces of information from our graph. The last part is to find the phase shift. And to find the phase shift, what we want to do is think, okay, where is the middle? Find the axis. Where does the graph start at the axis? And that's this point here. Then I said, okay, what happens after that? Oh, it goes to the peak, then axis, trough, then axis. And that pattern is a regular sine x. It's not reflected, right? It is not reflected. And it starts at 0, which means it didn't move left or right. So for us, there is no phase shift here. Okay? So that's kind of how you break it down. For part B, exactly the same thing. I'm going to break it down for you, but there's actually two answers for this question. And they're both right. So I'm going to draw peak and trough once again. That's going to allow me to calculate my axis, which is y is equal to 7 plus 3 divided by 2, which gives us 5. So I'm going to draw my equation of the axis there. That gives us our amplitude. I think you can clearly see our amplitude there. That's 2. So our amplitude is 2. And now we have to figure out phase shift. So up until here, everyone following stepwise? Everything's good so far? Draw peak, draw trough, find the axis, find the amplitude. So those are the 4 steps that we've done so far. Okay? The next step, figure out where does the graph start on the axis. Depending on where you choose, you will get 2 different answers. in red, let's say one student chooses here. Oh, I see that it starts there. You're going to get a different answer from a student that chooses here in black. And I'm going to show you. So first in red, it goes axis, trough, axis, peak, axis. Is that reflected or not?
Yeah.
Yes, this is reflected, right? Because we're going down first. So since we're going down first, this is reflected. So my equation needs to show that reflection. Second, we look at it, and the x value is actually negative 90. It doesn't start at 0, which means we have to move this 90, or it got moved 90 to the left. It starts at negative 90. So it's a phase shift left by 90, because it starts at negative 90 here. So my equation for my red one would be negative 2 sine x plus 90 plus 5. So that would be in red. Okay. If you are a student who saw this point first in black, then you would have seen axis, peak, axis, trough, axis. Which means for the student that picks the black points, for this student, it's not reflected. However, it is phase shifted, and this time it starts at 90, which means for the black lines, it's phase shifted right by 90. So their equation is going to look slightly different. It's going to look 2 sine x minus 90 plus 5.
Mr. Choi, I have a question. Why can't you start at like at the is that 3? Yeah, 3. The point 3.
So because we're working with sine, that is a good question. Because we're working with sine, the sine x graph actually starts at the 0 point, or at the equation of the axis. Sorry, wrong words. So it starts at the equation of the axis. So we want to look at a point that starts at the equation of the axis, because if we look here, it's kind of hard to figure out what the phase shift is, because that's not where the sine x graph starts, right? So that's why we're purposely choosing our first point to be on the equation of the axis to make to take account the shifting that we can easily see. Hopefully that answered your question there.
Yeah, it did. Thank you.
No problem. So there are two answers for this. Depending on if you chose the red point to start first or the black point to start, you might get slightly different answers, but both are correct. Okay? Any questions? Any other questions? Okay, let's move on. Going down here, we're almost done. Question 7, match each equation with the corresponding graph. Okay, I think this is pretty straightforward, right? But let's make sure we follow that same rule that we did before. If it helps, what stops you from drawing those peak and troughs and then the equation of the axis? That should help out a lot. What does that tell us? The amplitude is 2. Oh, I can see the amplitude is 2, right? There. It goes down first. Oh, there should be a reflection. And the amplitude's 2, which means the only option is B. That's the only one with the reflection and an amplitude of 2, right? So as you start getting comfortable identifying peak and trough, as you get comfortable, you don't even have to draw the lines, right? You start getting comfortable with identifying it and seeing where does it start, where does it go, you start getting comfortable with finding these things out much quicker. For the second one here, you should be able to notice similar idea. The peak and the trough are the same, but it goes up first, which means this is C. Right? And I think it's clear to see which one's which here, but I'm going to break down the last one for you. So question D, once again, let's break it down. Peak, trough, equation of the axis is in the middle. Once we have that down, this is our starting point, which is x equals 45. Okay. So that's going to be x equals 45. So it starts at 45 to the right. So it would be a phase shift of 45 to the right. And the amplitude is not 3, it's 0.3. Take a look at the scale. Be careful with the scale here. The scale is 0.1, so this amplitude would be 0.3. So the scale, you don't want to get caught with the scale there. Take a good look at the scale before you state your amplitude. Okay? Otherwise, that's that one there. And the last question. Last one of the practice test. Question 8. The height of a rider on a Ferris wheel in meters can be modeled by the function h of t is equal to 9 sine t minus 90 plus 10, where t is the time in seconds you're on the ride. Okay? Graph the function. Okay, let's graph it. What do we draw first? That's right, equation of the axis. I feel like I'm on Dora the Explorer and I'm Dora. All right. So we draw the equation of the axis. We draw the peak. So the amplitude is 9. So I'm going to go 9 above 10, which is 19. I'm going to draw that line. And then 9 below 10, which is 1. And I'm going to draw that line. Okay. So there's my equation of the axis there. And my peak and my trough. So I'm going to indicate those first using my amplitude, using my equation of the axis. And then we have a phase shift of 90 to the right. So remember, it's not reflected, so we're going to go axis, peak, axis, trough, axis, right? That's the pattern that we're going for. So at 90 to the right, we should be looking for axis.
Wait, mister, why is
Yes.
it at 18 again? I mean at 19.
Because the equation of the axis is 10 and the amplitude is 9. So we go up 9.
Oh, okay.
Yeah. And then same thing other way, 9 down, which is 1. So since we know that's 90 here, and the next point should have been 90, which is 180. So 90, 0 plus 90 is 90. 90 plus 90 is 180. That's our peak. 180 plus 90 is 270. That's our axis. 270 plus 90 is 360. And then 360 plus 90 is 450. Okay? Now, there's a lot of extra space here. But if this is a pattern, you should be able to fill in the rest of the dots that are missing. And it should look like this. And these are the red dots that I'm going to fill in now. Can everyone see that? So the black dots are what I drew, right, with the first transformed 5 points. And since I know it's periodic and it repeats, I should be able to follow the pattern to draw what happened before and what happens after. Then I can draw a nice, neat line going over everything, which I will have a nightmare doing as follows. Wow, this is terrible. Don't look at me. I'm going to give up very shortly.
Mr. Choi, would you take points off if we didn't do the red dots on a test?
maybe 0.5, not a full mark. I would like you to fill in the graph as much as possible. That's my main thing, right? So start with the 5 points that were transformed from the regular sin x graph, and then try to plot the rest using the pattern that you see. That's the goal. That's what I
What
want you
is
to do.
the red dot for again?
The red dots are the dots that I filled in using the pattern that I see.
Oh, okay, okay.
Right? So I'm not going to draw it. You guys can please draw a line curve through it. Like I'm terrible at this. I don't know why. I do this so much better on paper. Actually, okay, I messed it up. I was going to say that's not too bad, and then I completely messed it up at the end. Okay, anyways, there's your sine graph. Okay? Now we answer the 6 questions. What's my maximum height? No one should have an issue with this question. Thank you. 19. 19 what? It would be 19 meters. Don't forget your units. Minimum height, 1 meter. It's the trough. How far off the ground is the center of the Ferris wheel?
10 meters.
10 meters. The equation of the axis. Very good. What is the radius of the Ferris wheel? What is the radius of the Ferris wheel here?
9.
9. Josu and Sydney. Yes, 9 meters is correct. It's the amplitude. If 10 is the center, then the lowest it goes is the radius, and the highest it goes is also the radius. Because
So
if we
when
think
a
of a
question-
circle,
When a question asks like for the radius of it, do we just find the amplitude?
essentially, because when you're working with a circle, right? If the center is 10 meters off the ground and then the radius is to the edge of the circle, the lowest point from the middle is also the amplitude, which turns out to be the radius. Right? So that's the connection I want you to see there. How many revolutions do you make on the Ferris wheel?
So, Mister, the radius is always the amplitude. It doesn't change.
If it's a circle, yes.
Okay.
Part D, how many revolutions do you make on the Ferris wheel here? From beginning to end, from x equals 0 all the way to the end? Yes, 2 rotations. We start from 0, we go all the way to 720. You went up and down twice. So that'll be 2 revolutions. Okay. So in this case, once again, we wanted the red dots because the question asks you or told you that x represents time or t represents time. So we want to fill in all the dots that we can. And then part E, how long does it take to travel once around the Ferris wheel?
Is it 450?
Not 450, 360. From 0 to 360. It doesn't matter where you start. What another way of answering this question is, what is the period? That's what it's asking for. Right? So the question here, yes, it's asking you a different question, like how long does it take to go around the Ferris wheel? Another way I can ask that in a knowledge question would be, hey, what's the period? Right? How long does it take? So it doesn't matter which point you pick. From here to here is 360. From here to here is also 360. And don't forget to put your units seconds. Right? Because we're talking about seconds. And that was the practice test, or one of the practice tests that I gave you. And that's almost our hour for today. Your test is tomorrow. We will take up the second practice test a little bit, not every single question, but a couple questions, because the second one has an answer key to it. So I think there should be less questions on that one, but if anyone wants me to go over some quick things tomorrow before the test, that's the time to do it.